I want to rotate the phones out.
All right, this is probably the presentation you've all been waiting for, right? So anyway, I don't need to go over who I am again, so we'll just kind of skip that. Let's talk about some of the things that, driver type stuff. And the ACPI driver is a driver. The current version is 323.12. It has had a few minor updates. It now supports all the way through ACPI version 6.1. Some of the recent changes have been, ongoing enhancements to handle some of the newer vendor-supplied firmware, such as newer ACPI and newer BIOS and newer whatever in the different hardware that people ship to you guys. So that's an ongoing thing. Whenever I see a new problem, usually a ticket's created, and we'll handle that pretty quickly. One of the major things, I guess it's a major thing, I wrote an improved heat manager. This greatly improves the speed of allocating memory objects inside the PSD and reduces the memory footprint of the PSD itself. You will see faster boot times on some hardware by a little bit. Let's see. And we're always updating the ACPI CA from Intel, which is what got us all the way through to version 6.1. In the daemon, I made some changes to the power manager to kind of make sure it keeps track of which CPUs are running a little bit more efficiently. Most people would probably not notice that, but I noticed it, so kind of got fixed up a little bit.
Is that something that affects the, some machines tended to overheat under any operating system, and we were horrible, and we're not horrible anymore?
I suppose that's possible. Mm-hmm. There are two actual changes to that. One of them was it keeps track of CPU usage a little bit more efficiently and will switch to CPUs more quickly than it used to before. So that's really the main thing. And the other thing was it was possible that other applications could interfere with the ability to just turn CPUs on and off. I have kind of circumvented that, so the daemon now keeps, if somebody else switches them back on, it'll shut them right back off again. So, Multimac, it really hasn't been, a new version hasn't been released since late in November of 2018. And of course, each release is a bundle of a bunch of drivers, and each driver has its own version number. Most of them in that bundle were 1.1.4, with the MMRL being 0.1.3. The most recent changes in there, just in case you're not already running the current version, there were memory management enhancements, mainly to handle the transfer buffers a little bit more efficiently. There was better inter-module linking. I don't know if everybody knows, but Multimac is a combination of a FreeBSD driver, the actual source code taken right out of the FreeBSD sources, compiled on OS2, and then linked to a library that I developed, which produces a native OS2 driver. And this inter-module linking is what creates the links between the FreeBSD modules and the OS2 code. There was a fix in here to fix deadlocks transmitting packets on fast computers. So anyway, these were some of the recent changes. There was also interrupt handler improvements, because one of the major differences between FreeBSD and OS2 is the way interrupts work. So there's a lot of massaging of the interrupt handlers in my code to make Multimac stuff work. Let's talk about, USB. We don't need to cover that, do we? current version of USB is 12.03. That was recently released. It is, of course, a pretty much entirely 32-bit driver stack now, all except for audio and the MSD, mass storage device driver. The 32-bit drivers are significantly different than the old 16-bit stack. It's not just, yeah, we moved over to 32-bit. They are structurally different. There's a lot of, quite a bit different in the architecture and the way the code works. One of the things that you can see is faster code execution. Not necessarily faster data transfer, but faster code execution, which means your CPU overhead will be lower when running these drivers. Large sections were completely rewritten, particularly memory management, inter-module, inter-driver communications. These are all completely redone. Like I said, memory management, of course. The inter-driver communication is 32-bit now, rather than going through the old 16-bit method that the old drivers use. And as of, like I said, less overhead, but as of 12.03, there are improvements, bug fixes actually, that will never be backported into the 16-bit drivers. So there are some improvements that there are systems where the version 12.03 will work where the old 11.17 won't work. Let's talk about how all these drivers fit together. This is kind of an interesting picture of how they all fit together. At the bottom, you have the hardware drivers, the HC drivers, this USB 1 drivers, and then the USB 2 driver, and then the USB 3 driver. Everything talks to USB-D, like I talked to you guys yesterday about. Then there's the human interface driver, which talks to the USB mouse and keyboard, and then the printer driver, COM port drivers, and the USB calls driver. Then these ones in pink, these are the only 16-bit drivers left, and they talk through a little wart on the side of USB-D, which lets them talk to the host controller drivers. That's kind of how everything fits together.
Quick question on that. There used to be something called a USB modem. Is that?
Well,
is that just a COM? Is this a COM driver? Or?
Yes. Actually, the USB COM technically is a modem driver,
okay,
but it works for regular serial devices. And there actually were two. There was a COM and a modem driver. Now the modem driver is called COM, and I don't know what happened to the other one.
Okay.
Nobody uses it. USB 3. Yeah. USB 3 required a significant change from how things used to work. A lot of things changed. Device enumeration changed. When you plug something in, the way that the system finds it and attaches it to the system, this changed quite drastically because USB 3 works differently. So that actually affects everything. The way hubs are handled has changed quite differently, mainly to accommodate USB 3 mechanisms. And these changes affect the USB 1 and the USB 2 controllers as well, not just USB 3, which kind of makes this a much larger project than I had anticipated originally. One of the problems that I have had is hardware has been quite problematic in that it doesn't actually work the way the spec says it's supposed to. Yeah. I use the FreeBSD USB stack to kind of see how things work and model my code after them. It's really, really strange because I will be watching the FreeBSD driver work, and I actually put debug code in there to watch the bit patterns as they're written to the hardware. If I do exactly the same thing, it doesn't work the same. I can't figure out why that is, but I figured out what I have to do differently. So it's really, really strange. In addition to that, the reason I couldn't just port the FreeBSD driver to OS2 is the architecture of the way the USB stack works on OS2 is totally different. It's not even compatible. So basically I can take the hardware algorithms and I can take some of the hardware code and model my driver after that, but the way the entire stack works and the way all the drivers talk to each other, the way enumeration works is different. So adapting that, and plus not only that, but the way USB 3 wants to do things is different than the way USB 2 used to work. So things change quite a bit. It's a lot of work overhauling the entire stack, including the USB 1 and the USB 2 drivers. And if you imagine that, having to change device and enumeration, the way the kind of data flow works, and then not break USB 1 and not break USB 2 in the whole time, you're talking about a big project because you got to keep all the way USB 1 works, you know, the OHC driver, the UHC driver, the EHC driver, and the XHC driver all has to be in my head at the same time, and the USB D driver all in my head at the same time because any change affects all of that stuff. It was a monster task.
Question. What did the folks like at FreeBSD do? Did they actually build a separate subsystem for USB 3 and try to leave the other stuff alone?
No, everything got modified there as well.
So they just had more people to write the code.
Yeah, they kind of restructured everything. Yeah, and then actually in the FreeBSD code, a lot of the logic for some of this stuff got moved into the USB-D port module in there. Where in ours, it's yeah, I probably could have tried to do that, but it would have broken a lot of stuff. So it stayed in the USB 1 and 2 drivers, and then in the XHC driver, I just kind of duplicated it. It's just to make my job a little bit easier. So we do have a USB XHCD.sys driver, and it is working, except for two remaining issues. One is ISO support is still not implemented, and the reason that's not implemented is because that was on my list, last on my list to do. And something else got in the way. Primarily, super speed mass storage devices have problems when operating in super speed mode. They work perfectly fine when operating in high speed mode. But apparently, and I didn't know this when I started this, super speed devices are very error prone. Maybe because of the speed. They generate errors like crazy. And the error recovery doesn't work. Or it's very, very slow. FreeBSD gets exactly the same number of errors at exactly the same rate my code does, but they recover quickly, and you don't even notice it. My code doesn't recover quickly, and that's the problem I'm currently working on trying to fix. It does work, and on the most systems, it will run to completion, but you could take several minutes per maybe 10K of data transfer, which is not really fast. So that's current state of the USB 3 drivers.
Is that an election you make, the high speed versus super speed, or is it the
No.
device that makes it, or what?
No, and that's a good question because that brings me to the next thing. Let's suppose, this will answer your question. Let's suppose you have an XHCI host controller, and just because I didn't have enough screen space, let's suppose it has 6 ports. And a USB 3 controller, an XHCI controller, will have a number of super speed ports, and it will have a number of normal ports. Okay, and they are separate in the hardware. Now, let's suppose you have a system that has 4 connectors in it. How would you imagine these get connected to those? I'm sure this is something that's confused everybody for a long time. It's confused me until I discovered how it actually works. This is one way it might be connected. You might have this super speed port connected to a USB 3 only connector. You might have this super speed port and this standard port connected to this connector. and this super speed port, and that non one connected to this connector, and you might have this standard port connected to a USB only connector. How many people realize that when you have a USB 3 device with the little blue color in here, there are actually two completely separate sets of pins in this connector?
I realize that.
Not many people do. And there are two completely separate sets of pins in these dual port connectors. And one set of pins is connected to the super speed port on this controller, and the other set of pins is connected to the non-super speed port of the other controller. If you take one of these and stick it in your port but don't put it in all the way, it will only connect to the normal pins, and it won't connect to the super speed pins, and then it will operate as a high-speed device and won't operate as a super speed device. In fact, if you stick it in and don't get it in straight, it might not connect to the super speed pins and will operate as a high-speed device.
Which is slow but not terrible. It's better
No,
than having that error
correct.
rate problem.
You won't have that error rate problem. Then, that's not even the half of it. So, if you have a high-speed hub and plug it into one of these dual ports, it will only connect to the low-speed or the high-speed pins, and then you will have USB 2 only connectors there. However, a USB 3 hub actually has two hubs in it. It has a high-speed hub and a super-speed hub in it. The super-speed hub connects to the super-speed pins, which goes to the super-speed port, and the high-speed hub connects to the high-speed pins and goes to this port.
If you plug it in on the right side, it just has the super speed path?
Plug it in the right way, I think is the proper way to
Plug it
say
in the right way.
Yeah.
If you plug it in, everything's normal, you plug it
No, that
in.
one on the right side where you say USB 3 only.
You're right. This hub won't connect to anything if you plug it in this port.
That won't work at all?
No,
Or you
this
mean
one
the hub
won't work
that's
at all.
High speed, I see.
Yeah.
Right. So when you plug a USB 3 hub into one of these ports, you will actually see two hubs show up in your system. You will see both of these show up. And then you can have the same combo port here.
Well,
Yes.
nothing connected.
Is it possible if you plug it in slowly that the USB 2 gets seen and the other one's ignored?
Yes, it is.
I guess
Because
the
I think I've
moral
seen
is
that
don't
happen.
buy hubs with cheap
Yes,
connectors.
it is possible.
Couldn't you just have provided plugs to put in the, you know,
Well, you know what? If you plugged a high-speed hub into this port, which this is a USB 2 and 3 port, then any USB 3 device you plug in here will only operate at high speeds because the USB 3 path isn't there.
Yeah, but that's sort of easier than getting two hubs and keeping track of them, and the fact that they're really the same device.
Well,
Or
think
doesn't it
about
matter?
all this, and now writing a driver that handles all this stuff.
Mhm.
When all you used to have was USB 2 architecture. Now, this next picture is actually in the USB 3 spec.
Well, they tried to explain it.
Have a look at this
They
thing.
tried.
I just want to know who thought that was a good idea.
Well, I was asking that same question. And, you know, they got integrated hubs, and they got embedded hubs, and they got, you know, if you track this is the USB 3, this high super speed running all the way through to here and here through a couple of hubs. You got this USB 2 port. I mean, look at how this confusing this can get.
no.
So anyway, so now when you've got all these ports on, all the connectors on the back of your system, and some are blue and some are teal and some are black, and which ones are USB 2, which ones are USB 1, or which ones are USB 3, well, it's not so simple. And not only that, but if you have connectors that have a super speed path and a high speed path, they don't even have to go to the same controller. The super speed can go to an XHCI controller, and the high speed one could go to an EHCI controller. That's legal.
And you have to keep track of them.
The software has to keep track of all this.
And you better pray you're not too colorblind.
Yeah, well, so anyway, it's confusing stuff, and maybe this helps you understand a little bit about when you've got one of these and you're trying to figure out where to plug it in and why it works in this one and why it doesn't work in this one, why it's fast in that one, why it's slow in this one, that's why.
How common is the USB 3 only port? I've never even seen
Not
one.
very common. Not very common at all. But I imagine there's probably going to be more of them coming out. I have a system that has teal colored ports on it that don't work for me right now, and I don't know why yet.
Well, I say that when I get home to be checking all my newer boards, because now I'm curious.
Yeah.
Yeah. Well, it's something that complicated. The quality of the hardware may have something to do with it.
Maybe so. The super speed, well, I shouldn't say that. That's not true. Okay. Anyway, moving on. Panorama got currently updated. It's now at version 1.15. Recent changes have been, I restructured the Warpin installer to copy the installation files to a temporary location and then delete them when it's done. The old one used to leave it laying around. The protect mode interface has been completely redone for better compatibility with various systems. Most people would not even know anything happened, but that did happen. It's actually a pretty big change. The EDID compatibility, I added support for 1.4 version 1.4, which is now available. The national language support is fully implemented now in Panorama, so it will support various languages. The only thing this affects is the setup widget, really, so that'll appear in different languages, so that's fully functional now. And some MTRR issues got fixed. Some bizarre hardware that I came across had some issues, so that got fixed. Where that actually got fixed was in grad.sys. Because if you remember yesterday, we talked about what grad.sys does. One of its functions is support for changing the MTRRs, and that's where this actually got fixed. This is included when you install Panorama. It's included when you install Snap, and it's also included if you install the standard grad drivers. The current version is 2.02, just in case you do a build level check on it. Some embedded systems don't have any MTRRs. I discovered this the hard way.
You mean
So
be a
now
trap.
I got a trap. And it doesn't trap at a convenient time. So it was kind of hard to track down. But that's been fixed. It doesn't trap anymore. And some newer systems apparently set write combining for the video memory automatically. And I wasn't checking for that, and I would just try and set it a second time and it would fail, even though it was already set. So now it's enhanced to detect if it has already been set.
What's VSF?
Vendor supplied firmware, BIOS, ACPI, whatever.
The stuff that's going away.
No,
Well,
vendor supplied
even-
firmware will never go away.
Even with VBE, when VBE goes away?
Never.
Okay.
You will always, your system won't run without a BIOS in it, without some sort of vendor supplied firmware that's in
Yeah,
ROM.
that's true.
Disk drivers. ACPI driver is currently at 2.06, even though some people may have seen a 2.07 floating around. The officially released version is 2.06. These are some of the things that got changed. The smart utilities will work. This is recent. This has been out for a while, so you may have seen this stuff already. I removed some startup restrictions simply because some vendors don't supply the right stuff or the stuff they used to, so it will still load and run. This is the latest feature. It's a feature that will ignore unusable disks, and unusable means a non-MBR disk. This feature was added specifically so that you couldn't accidentally corrupt a GPT disk. And some of the debug messages got cleaned up a little bit. By the way, feel free to blurt out questions if you have any as I'm going along. FAT32 is in active development, primarily to get a working cache and better performance. So far, the cache is working and performance is better, but there still are some problems that need to be addressed before it's officially released. I'm not the one working on this, so that's about all I know about it. UniOdd is really not in development. However, some work has been done to improve some of the mixer functionality for some systems, and it has actually helped some systems. And when we finally get done testing, make sure it hasn't broken anything, there'll be a new version of that out as well. Other stuff that I kind of work on, my test log program, it does get updates frequently still, mainly to fix things whenever somebody has a problem or something new. Plus, the test log program is very closely tied to driver versions. So sometimes if a new driver version out that has a different memory structure, I'll need to have a new test log program for it.
Could you say just how do you update the test log? Sometimes I see two with the same version number, or
Yeah. Well, if I incremented the version number every time I did a new release, we'd be in the thousands by now.
yeah.
I essentially bumped the version number for major changes.
Okay.
Minor syntax, like if I have a misspelled word or some very minor things, the test log program has a date and a version number.
Okay.
It will always have the build date.
Yeah.
Like when you run it, it has a header at the top that says created by test log version number with a date there.
Yeah.
The date is really the thing you want to look
So
at.
pretty much, if I'm going to send a test log, download a new one.
You should. If you've got the same major version number, it really doesn't matter.
Oh, okay.
You know, and unless you're working with the really new drivers,
Mm-hmm.
pretty much any recent one is good enough.
Okay.
Any good recent one is good enough.
Yeah, my approach is, if I'm gonna generate a test log, I go check for you. It's just
Yeah,
simple.
Yeah.
it's good. A good sense. It's small. It doesn't take long to download it. It doesn't take long to just. It's a warp-in installer now. It's just install it and run
You
it.
need a desktop object.
Yeah, a desktop
really
object.
want.
Yeah, I suppose. Always try, like you say, always try and use the latest one. Beware of this. I say this every time, but people still don't realize it. I have people.
Oh.
I have it running it, and it's empty. The data's not there. The debug buffers and all the drivers are cleared when you run this. In other words, there's buffers. All the drivers have buffers that keep debug data in them. And from boot time, it keeps all this data. When you run this test log program, it copies the data out of those buffers into the log file, and then the buffers are empty. So if you run it again, there's no more debug data. Until you reboot, create the problem again, then the debug data is there again, and then you run and copy the debug data out of the drivers into the log.
Is that because of the drivers? If I copy from the driver, it just clears it anyway?
Yes, yes.
Okay.
Yeah, the debug data doesn't stay, it's not
I
persistent.
mean, even if I do it from
It's
command
really
line.
just.
If you do it from the command line, yeah.
Yeah.
It's a design choice.
It's a design
Yeah,
choice, right.
Yeah, because the Danish drivers
Because
preserve it.
I have sometimes when I do things, I have a program that'll loop copying these things, and I can keep a long stream of data going. Like if I have lots of repeating error or something, I can keep megabytes of data that you can't. There's only 64K buffers in the drivers.
Yeah, of course.
Yeah. Okay, I think that is. Oh yeah, this is the other thing.
Why would you want to do
This is pretty important. You can't have a problem, reboot your system, run a test log file when the problem doesn't exist. This is you got to capture the data when the problem is happening, not after you've reset the system and rebooted. Now sometimes you can't do that. If it hangs the system, you can't do that. And there is valid data in the log, like about your system configuration, about the versions of files you're using and stuff, but it can't capture the actual problem unless it actually exists. Like if you're having a network problem and your network's dead, run the test log program while the network's dead. And maybe we can see what the problem is. Don't reboot it, get the network working because you got to upload it, and then run the test log program. No. Run the log, get the logs, capture the logs while the problem exists, if you can. And I guess that's it. I always have this in here. If you do have problems, please read the docs. Read this especially. Use it as like a checklist.
You mean that thing that you click over every time?
Yeah, the thing you just skip over.
Yeah,
that thing. Right. Anyway, that's about it as far as drivers go.
You didn't mention Wi-Fi, or did I miss it?
I did not mention Wi-Fi. Haven't been working on that lately. So there's been no recent progress on that.
The MSD driver and the audio driver, any plans to move them to 32-bit?
Well, the audio driver, probably not. I actually tried doing that. I tried working on that. And the interface to MMOS2 is heavily 16-bit. And it would be a massive effort to thunk all of that stuff. So it's probably not worth converting the audio driver to 32-bit. The MSD is probably doable and probably will get done one of these days. Anything else? Okay. Well, that does it for drivers for you guys. You're welcome.